everybody, we are back, and I'm using Streamlabs OBS again now. So if you're here in the chat, feel free to say hey. Sorry I had to remake streams. I hope people are here, but check this out. Check this. Hey there, we are currently aware of an issue with using ultra low latency setting. Can you turn that off and try to stream again, please? Elfheather name is sarcasm powered. That really gives me confidence. But no doubt, I turned off the ultra low latency. I should have tried that this morning, but I don't know what they did with updating Streamlabs, but they did something that then caused an issue to arise. So remember this morning I said things just weren't working. You wake up this morning, you go to stream like usual, you click the buttons for things to stream. So I said for some reason when I try to stream, it says the latency settings are not correct, nothing has been changed, and won't let me stream to pre-made YouTube streams. So I changed the latency, and I'm back here on Streamlabs OBS now, which means MewBot exists in this universe. We got MewBot, we got everything's back. Everything's back to normal. Streaming on the Streamlabs OBS. That's why I have OBS as a backup, though. So I did have the backup ready this morning, so I'm glad that we could do that. If you're here, say hey in the chat. I don't know who's here. I kind of had to hop around a little bit. We'll see who's here. Got into office hours a little bit early today because I got the meeting at 1:30 your time, 12:30 my time. Let's hop back here to space. If you're here, might need to send out a link because I've totally gone back and forth. Let me send out a link to everybody. And so I'll send out a link, say office hours stream. Here is the current link to office hours. And I'll say click here. And we'll send out this link to office hours. Make sure it's the right link. If you're in the chat, feel free to say hey. There we go. There's the link to office hours. We'll see if anyone joins in. We'll hang out here for a little bit. We can answer questions. But yeah, so I'll see how the stream went this morning. See, now the background's working. Streamlabs OBS is we'll make your background work. But yeah, what questions are there? We did a lot during office hours yesterday. We did a lot during class today. We did a lot of questions. Hey, Layla, good to see you here. Did you see? You might not have seen it. I had it up a moment ago. But check this out. Here you go. Check it out. So literally this morning when I go to use Streamlabs OBS, it wasn't working, and it was the stream just wouldn't start. So I was messaging this person on the Discord right here. You bet. Let's do that one next right here. And so this person was saying, we are currently aware of using the ultra low latency setting, which is what I use for Kahoots. Ultra low latency is the ability to do Kahoots more in real time. You need ultra low latency. You don't want, because latency can be as much as 15, 20 seconds, and that's going to totally destroy a Kahoot. So hey, it's the morning of a Kahoot, and there's an issue using ultra low latency. So I did have to luckily switch from, you can see down here on my menu, I've got Streamlabs OBS, and so that's what I'm streaming through. And then I've got OBS right here, which is open broadcast software. So I've got both of them ready to go in case one of them has an issue, because I use Streamlabs and the other one. Let's get that question up though. Let's check it out. So I'm not crazy because I've got all my buttons set up here. This morning, if you noticed, I had to click around more because there's a lot of things set up right here, ready to go. I've got MewBot here. We've got a lot ready to go. Yeah, that's the issue. I had a whole bunch of issues getting it going even now. I don't know what they're doing. I don't know what they changed. I don't know why they broke their program. And so I sent out that link. You probably got the link right there. So sorry about that. It's just one of those random streamer issues that can happen where the people who make your software end up breaking it on you, and then they're like, oops, we broke the program you used to stream your class. And you're like, thanks, that's really good. I've had once or twice where there's been issues, and I've been doing this for 2 years now. It's pretty rare, so this is just one of those rare instances where they changed the software and there's a software issue. And then their backgrounds are not as good. OBS was actually doing better. I think this weekend, if I have time, I'll be trying to bring us over to OBS. And I'll be canceling the question on Discord you posted. The answer to that question is true, right? Yep. And don't take the test yet, because we're going to put the Kahoot questions in the test. So that one was true, right? I believe. What question did I post in Discord? Another guy's getting help right now. Their answer to me basically is, can you just not use the thing you're trying to use? He's building his custom tip page right there. I'd love to check out like these people's channels right here, like to go and it's interesting. They look like they got cool channels because I'm on like their streamer thing, but I'm gonna be leaving them. The proper. Oh wait, no. No. So the answer is false right here. The answer is false. False. Proper phrase. Sample statistics help us estimate population parameters. So the answer is false right there, Ritu. The answer is false. Sample statistics help us estimate population parameters. So that would be false right there. That is a false statement. Let me get Layla's question right here. We're doing the junk mail one. So the junk mail question. I've got this way too big on the screen. It's just so crazy. It's always the fun thing when your software breaks. Streamlabs OBS, you're going away. That was it. You can't hang around because you didn't work. You broke. And we can't allow that. Here we go. We got the junk mail question ready to go. Let's hop over and do this. I get everything here so good. I've got my transitions. I got my ability to remove myself. Oh my gosh. There we go. And then Streamlabs breaks. So let's take a look at this question right here. Decision trees are on this exam. That is correct. Decision trees are on this exam. Decision trees are on this exam. I'll send the reminder review material. It's on the Stat21 homepage. So if you're trying to review for the exam right now, just remember go to the Stat21 homepage, and the review material is all posted there. Review videos, review questions, review practice tests, all posted to the Stat21 homepage. So check it out. And we are making a 95% confidence interval. We got a bunch of information. Here we go. So what do we have? We've got here this, and we got here this, and we got here this. So what do we need? Use this information to complete parts A through D. Suppose a company wants to test the response rate of a new flyer. It sends it to 1,100 and from this, and this is a trick. That's a trick right there. How dare they do that? So be very careful. They're trying to make a confidence interval, and I think they said what % confidence? So what do you see here notation-wise, Layla? They want to make a 95% confidence interval. I'll go ahead and mark a 95% confidence interval is equal to a z-score of 1.96. So that's the 95% confidence interval, z-score 1.96. David M. Lane Applet in the chat. And we can go to the David M. Lane Applet here. And there's the David M. Lane Applet, 95% confidence interval, 1.96. But the notation for this problem is what? They're throwing you an extra number to trick you. So they're throwing you an extra number to trick you right here. This number right here, that one is not something we will use. I'll mention what it is in a moment. It's just not going to be used for this problem. Like, we're not going to use that to solve. It's not important. I mean, it can be used to check the 10% condition, which tells you what it is. We're using it for the 10% condition. So what are the other things in the problem right here? What are the other bits of notation? And writing the formula can be a lot of help. So writing the formula can kind of narrow down what we're looking for when we do p hat plus or minus the z-star, which we have the z-star up there. That's the % confidence we are and the z-score related to it. And now we want to find these values right here. And remember, once we find p hat, we can find q hat. So what is the notation right here for this problem? What is the 125? What is this? Yep, this is the sample size, and so that is n. That's little n. This right here is actually big N, and that's the population size. We won't use the population size for this problem. That doesn't stand for normally distributed. It stands for population size is 200,000, but we're not going to use the population size. It's just not going to be utilized in this problem. And this over here is x, and from x over n we can get p hat. So x over n equals p hat. P hat is equal to 125 divided by 1140. And p hat is going to be equal to 125, 1140. So it's about 11% or so. So that is p hat right there. 0.1095 is p hat right there. 125 is x, correct. And that's how we get p hat right there. So with this problem, we're going to plug in these numbers. And let's go ahead and start plugging them in. Now we need to know how to get q hat, well, 1.96 right here, Q hat is going to be 1 minus P hat. So there's P hat. And then Q hat is 1 minus that. So 8905. And then 1140. And here we are right here. So there we go. And then square root. That's the margin of error, and there we basically have it. So 0.018.01812. There we go right there. That's got the confidence interval right there, and we'll go ahead and solve that here in a moment. A latency issue person thing. Man, they had to break my thing. Everything was so perfect. So the upper portion of the interval, 125 divided by, there's that, plus this, that's 12.77 or 12.8. And then we just need to resolve again. We're just finding P hat right here. There's P hat, and then there's minus the margin of error, so 9.2. That should be correct. Should have carried everything out correctly. You know what I can do? So R uses a slightly different way of calculating this, but what's really great, and this is 95% confident, R uses slightly different calculations, but we should get very similar answers. So is it very different? I don't think it was very different. 9.2 and 12 point, yeah, they use the chi-squared distribution to calculate, so they use slightly different calculations, but my answers are pretty similar, so that gives me confidence in the answers. But R uses a little bit different of a metric. I wish... Let me see something real quick. Surely someone has a 1 proportion Z interval in R, and... Surely, this is not the wait, prop test. Is there in prop? Wait, correct equals false. Yes. Oh my gosh, is that literally it? I love how it's correct equals false. Oh my gosh. Wait, but that's different. Ooh, I hope I got the right answers. So are they the value of the Pearson chi-squared? I'll take a look at that later. Prop test uses the Yates continuity correction, which is important if either, if the successes are less than 5. Okay, cool. Explain what this interval means. We are 95% confident that the true proportion is contained in the interval blank to blank. So one can be 95% confident that the percentage of people who will respond to the flyer, because we're looking of people responding to the flyer, so they're trying to get a response rate. I am 95% confident the true proportion of people who respond to the flyer is contained in the interval blank to blank. When we are 95% confident, so I'll have you help me out with this one here, Layla. When we are 95% confident, that means we are 95% confident that what? Is it A, B, C, or D? To be 95% confident, what would it mean? So we are saying 95% of the time, intervals will contain the true proportion. It's right up here. This is what we're talking about. When we say we're 95% confident, it's that 95% of 95% confidence intervals will contain the truth. So when we take intervals, 95% of the time, these intervals will contain the truth, and we're talking about samples. So which of these sounds like this right here? 95% of all random samples will respond to the new flyer? No. 95% of all random samples of size 1,140 will produce confidence intervals that do not contain the truth. Or 95% of random samples will create confidence intervals that contain the truth. So that's the answer right there, and that's what we're visually showing right here, that 95% of random samples of a certain size doesn't matter, will create confidence intervals that contain the truth. Sometimes the confidence interval does not contain the truth, sometimes it does. This green line is the truth right here, and 95% of 95% confidence intervals would be expected to contain the truth. Yep. So it doesn't really matter about the size right here. It could just be 95% of random samples will produce confidence intervals. The size is irrelevant. I mean, truthfully, it is for this size for this question, but any sort of size would just be 95% of random samples will create confidence intervals that contain the truth. The company must decide whether either to do the mailing list or not. Well, they want a return rate of 5%. If you were working for the company right here and you thought the true return rate was between 9.2 to 12.8, then would you say to do this mailing? Would you do this mailing? And I want to look at my answer right here real quick again. Would you do this mailing? Because I was getting slightly different things in R. Would you do this mailing? Yes, that's what it should be. So you want at least 5% return. You want at least 5% return. And you're thinking that the true return rate is between 9.2 and 12.8. Hey, Charlie, what's happening? Good to see you here. Would you do the mailing if you think the true percentage that will respond is between 9.2 to 12.8? You think the truth for this is between 9.2 to 12.8, and you want at least 5%. Yeah, definitely. The whole interval is above 5. So do the mass mailing, continue the streak, 100%. No questions wrong since Tuesday. That's how we do right here at Stat 201. No questions wrong. Which other questions are you wondering about, Layla? That was a good question right there. That was a great question. Let's hop over here. Let's put on a little music. Everything's working again. Let's hop over here to the main screen. Yeah, I need to switch to Streamlabs. I need to do it. I need to switch to OBS, not Streamlabs. I just switched to OBS because Streamlabs has let me down for the last time. The background stutters. Puppet Shark stutters. You do stutter, Puppet Shark. Tiny Puppet Shark stutters. We can't have that. We can't have that here. We got to be streaming strong, streaming well. No stuttering. I'm trying to find, while people are asking questions, I want a 1 proportion Z test that everyone's just saying prop test, which I was using prop test. And I want the one that doesn't use without the chi-square. I mean, I can program it myself, but I'd hope there's a function. Everyone's just been using the 1 prop. Someone programmed it. They really programmed a lot right there. Sure, let's go grab their function. Cool. It's a nice function. Let's go look at the function. So Charlie, this is some little programming in R. And basically what we're going to do is we're going to look at, so I already grabbed their function. Let's over here, see if people have questions on the main screen. Leanne asked, Canvas content number 7, you bet. Let's do it. I finished the homework and quiz, so you can just work on any questions you think I'm important. Awesome. Yeah, let's do Canvas content here. Let's do that. Let's go back and do Canvas content right after this. Oops, I decreased font size there. I'm going to look at this really quickly here. It'll just take 1 to 2 minutes. They wrote a function right here, and their function is called z.test. Does it produce the confidence interval? Let's just check. They do give the confidence interval. So we can just take our numbers from before. This is why coding's awesome. There we go. That's what we're getting on the calculator. And they're carrying more decimals. So the only difference we see probably right here is that they're carrying way more decimals than we are, because probably they're calculating the z-score more exactly. So the difference decimals we're getting differences here are just decimal differences at the end. And what's really great is, you know how our problem wanted us to, it does that. And then we could go to round, we could times this by, last little bit right here. Times this by 100, round to 2 decimals, and that should do it. Or was it round to 1 decimal? It was round to 1 decimal. Oh, it rounds up? That's what we got, right? 9.2 to 12.8. And there's our 9.2 to 12.8. So there's solving it with code with R. Solves it nice and neat for you. We could program in the function if we want. Let's go take a look at the question that I think it was Leanne had right there. Let's hop over to Leanne's question. So that's kind of why I like coding in R, just because you can do those things. You can create that code right there. And someone already created the code for us, the actual thing, and they're just returning a list. I just played that one. Let's go hop over to Canvas content number 7. Where's it at? Canvas content. I'm pulling it up right now. Law of Large Numbers Casino. Canvas content quiz number 7. Here we go. Preview. Okay, I think this one. Oh, there it is. Cool. We got it. You're headed to the Law of Large Numbers Casino. Let's do this. And here we are. So let's solve this. You ready? You are headed to the Law of Large Numbers Casino for spring break and plan to play their world-famous slot machine. The slot machine at the Law of Large Numbers Casino has 3 wheels that spin when you pull the lever. When pulled, each wheel spins and stops on one of the symbols. Assuming that the outcome of each wheel is independent, key rule for multiplication right there, and the other 2 wheels, cool. Each wheel, there are 10 equally likely spaces, okay? They're all equally likely. 4 skulls, 3 lemons, 2 cherries, 1 bell. Cool. If you play, what is the probability that you get a lemon and a cherry and a bell in that order? You get a lemon and then a cherry and then a bell in that order. So it's probability of getting a lemon and a cherry and a bell. So what are you going to do to these? When you see the word and right here, what are you going to do to these? So what are you going to do when you see the word and? Like you get a lemon and a cherry and a bell. That's what you're going to get in that order. Lemon and cherry and bell. Like the wheels are going to spin. Wheels are spinning right here. What are you going to do by seeing the and word? That's key right there. We see and we think what? That's like, oh, I need to what these probabilities together. See the probability of getting a lemon and a cherry and a bell. What should we do to these probabilities? Key thing we need to do here, since we're seeing and also we see independent. So we're assuming each wheel is independent of the last. Then we have and. So we have 2 rules that kind of might be used here. Not saying which one's going to use, but we have the multiplication, we have the addition rule. The multiplication rule has the rule or the requirement that the multiplication rule has the requirement that each one, great job, Leon, right there, is independent. So we need to have independence, and that's what we're going to use. The addition rule has that they're disjoint, and that's the word or, and we add them. So let's go here to multiplying these. The probability of a lemon is going to be 30%. The probability of a cherry is, yeah, that's correct. Probability of cherry is 20%. And the probability of a bell is 10%. So 0.006. Did I do, that's correct, right? So probability of lemon, cherry, and bell. Lemon, cherry, bell, that is correct. And it would multiply to 6 and move the decimals, 0.006. Don't round. Everything good right here. Jimmy and Carly are planning on having 2 children. What is the sample space for the experiment? Really? So when you think about the sample space, it's everything that could occur. While it's true that they could have boy, boy, girl, girl, boy, girl, they could also have boy, girl, girl, boy. So that's the sample space. It's everything that could occur. Can you also do the manufacturing? We might have it on here. We'll find the if it's not on this version, I'll do the manufacturing version too. All other things being equal, the larger the sample, the smaller the standard deviation of the sampling distribution. This is very, very true. The standard deviation of a sampling distribution, we'll find that one next here. You got it. We'll do this version of it, and then we'll find that specific one. Mu p hat equals p, so that doesn't depend on the sample size. But the standard deviation of p hat equals 2p times q over n square root. So all else being equal, if we increase the sample size right here, great job, Leanne. If we increase the sample size, this will decrease the standard deviation. I have a habit of not putting the equal sign when I write that one. I noticed that. So that'll decrease the standard deviation when the sample size gets larger. So the answer is yes, all else being equal, increasing the sample size will make for a smaller standard deviation for the sampling distribution. This is very true. Just decreases the variation, and that's part of the central limit theorem, tighter and more normal. The 3 conditions for the sampling distribution must be met in order to calculate p hat. Well, how do we calculate p hat? P hat stands for the sample proportion. So let's think about how we calculate p hat. P hat equals x over n, and I don't see any conditions right here. Why do we have the 3 conditions of condition 1, random, condition 2, 10%, condition 3, well, pause. Yeah, let's do that one. We'll do that one next too, Krista. You got it. Success, failure. What is the point of meeting these conditions right here? It's not to calculate p hat. What is the point of meeting these conditions? What is the point? Because it'll tell us that we can use the what shape. So the point is not that we calculate p hat from this. I mean, we will probably calculate p hat, but we don't meet the conditions to calculate p hat. We meet the conditions such that we know that the what. Like, what's the point of meeting all the conditions? Meeting all the conditions is to tell, a lot of notes right here. When we meet all the conditions, what? Oh no! There we go. When we meet all the conditions, it means that it's approximately normal by meeting all these conditions. So there's the conditions right here, random, 10%, success, failure. And if we meet all the conditions, then we have that it's approximately normal. I keep thinking around that. So the answer here is false. We do not need to meet the conditions to calculate p hat. A confidence interval is made from a confidence interval is made from a sample to estimate the truth for a population. I was already thinking about the next answer. I think that's got it. I think I didn't mess up any of the probabilities right here. Let's find Leanne's answer right there. The streak continues. Nothing wrong. I'd love to go the whole semester without getting anything wrong, but mistakes happen. You misread questions. You don't carry a decimal. It happens. Happens to the best of us. Let's find Leanne's other question right here. So we're going to find Leanne's other question. Let's go to preview. Can you do the manufacturing one? Here we go. A manufacturing company would like to investigate the effect of a new supplier of raw material. I'm going to need everyone's help with this. I'm going to have you solve it. I want you to show the work. So the company makes 7,000 of each items each day for its group, whatever. If the rate of defects are unchanged, the new material, they will use the new material. For this analysis, they take a cluster sample of 500, sure. And it says if the defect rate is greater than 3%, so let's just call it 3% right now, is the success failure condition met? So I need you to tell me, is it met or is it not met? We need to know the sample size that they're taking, and is the success failure condition met? So the success failure condition, we were basically right on it. Let's go rid of the notes. And I need you to tell me if the success failure condition is met or not. So we need to know for the success failure condition a few things. We need to know the sample size, and then we need to know either P or P hat. This one's using P because it's a sampling distribution of the sample proportion. So when we do this right here, remember, they're taking, so I need to know the two numbers for the answer to this. I will answer this, but I need you to tell me the two numbers that would tell me whether or not the success failure condition is met. This is what you need to calculate to see if it's met. To see if the success failure condition is met, you need to tell me two numbers right here. What are the two numbers? And you can see right here, we're talking about this right here. You're going to calculate. So calculate to tell me if it's met or not met. Let's try this right here. So it's like Brian's a 3% free throw shooter. So Brian's going to be over here. Brian is a 3% free throw shooter, and he shoots 500 free throws. I don't know how I made that one as a 3% free throw shooter. So it falls off the rim. So Brian's a 3% free throw shooter. Is the success failure condition met? We're just changing context now to Brian either he makes his free throws 3% of the time, he misses them 97% of the time, he makes 500 free throw attempts. Then is the success failure condition met? Is the success failure condition met? And how would we calculate this? So what are the numbers we need to check it? So we need to see if this is greater than or equal to 10 and if this is greater than or equal to 10. So what two numbers are you calculating? Yes, Leanne, excellent work right there. Yep. And then what is NP? I'll solve the other one for you. So Leanne, great job. Leanne calculated that 0.03 times 500 is equal to 15. And then the other one's going to be equal to 485. So that's going to be the bigger one. So there's 15 yeses, and does that make sense? Because you would go right here. It's gonna be a little crowded, but that's QNQ or QN. So it doesn't matter. Multiplication works either way. But we're just multiplying the probability of a failure times the amount and getting the expected amount of failures. So these are the failures right here, 485 expected failures. I expect to mix the basket 485 times. I expect to make the basket that many times. So is the condition met? Most definitely. And I think can you do the probability of arriving? Yeah, let's see. Do we have the bus arrival one on here? Did we look out and get them both? We got them both. Yay. Here we go. Ooh, this one's a little tricky. So get ready to help out again. You ready? Suppose the probability of a bus arriving on time is 56%. For the next 4 stops, what is the probability the bus is on time for at least one stop? Assuming each stop is independent. By assuming independence, What are we allowed to do to the probabilities? Now, I know this one's a little weird because you're like, if the bus is late at one stop, it'll be more late at the other. Like, it's more likely to be late at the next, because how can a bus be 20 minutes late at one stop and then be on time for the next stop that's 5 minutes away? You'd be like, that's impossible. Maybe we're just saying that the schedule updates. Like, when it stops at that, it updates, and it's like, okay, it'll be 5 minutes to this next stop. So, but you might say, well, wouldn't traffic on that? Yeah, I know. Assume independence. There's a lot of ways to say this would not be independent, but we're going to assume independence because that's going to be key right here to solving out the mathematics on this. Okay, so we have the probability it's on time. So let's draw right here. Probability on time, and then we have probability late. So the probability the bus is on time is 56%. The probability the bus is late is 44%. So the bus is either on time or the bus is late. And with the bus being on time being 56%, well, what is the probability? Let's say this. Let's think about this bus. You ready? The bus will either, let's write it down here. Two scenarios we got. Either, let's say, on time all stops. On time at least one stops, okay. Late all stops, or on time at least one. Put a little mathematics around this, and we can see what we're looking for now. Would you agree with me? I just want you to think of this as a statement. Yes or no in the chat. Would you agree with me? The bus is either late to all the stops or it's on time at least once. And look at what we're looking for up here. The bus is either late to all the stops, like every stop, all 4 stops, it's late. So, or the bus is on time to at least one. The bus is either late to all the stops or it's on time to at least one of the stops. So it's either late for all 4 or it's on time for at least one. It's like saying I shoot 4 basketball shots and I'm either going to miss them all or I'm going to make at least one. So there's only 2 scenarios that occur when you shoot 4 shots. You'll either miss all 4 or you'll make at least one. Those are the only things that can occur when you describe it that way. Because you either make all 4 or you either miss all 4 or you don't miss all 4, which not missing all 4 is making at least one. So when we do this right here, we've described everything that can occur. By doing this as everything that can occur, how would you go about comments, content? I know those limits. Oh yeah, here, I'll take a look at that one next right here. You got it, Leanne. Let's take a look at that one next. You got it. So late to all stops. This is where I need the help. So help out in the chat right here. How would I figure out the probability it's late to all 4 stops? Late to all 4 stops. How can I figure out the probability it's late to all 4 stops? Because it's either going to be late to all 4 stops or it's going to be on time to at least one. How would I figure out the probability? And we're trying to find this. I'm going to erase that for the moment, but that's what we're trying to find. So how would I figure out the probability it's late to all 4 stops? How would I figure that out? How would I figure out the probability it's late to all 4 stops? So we know the probability it's late. Like, here's the probability it's late to a stop. What's the probability of it being late to a stop and late to a stop and late to a stop and late to a stop? Keywords right there. What's probably it's late and then late and late? And I'm assuming that each one of these is independent of the other. What's the probability it's late to the first and the second and the third and the 4th stop? And so what do we need to do right here? Since we're saying the and, we're saying and, we're going to be multiplying these together because we're assuming they're independent. So the probability of being late to the first stop is this. Exactly. You multiply it 4 times by itself, correct. Sometimes people multiply it by 4, and I'm like, no! You won't multiply it by 4, you'll multiply it 4 times by itself. And so all we're doing really by doing that is raising it to the 4th power. And so we raise this here to the 4th power, and you'll notice now the or becomes a plus because we're saying either this or this. And then we're going to subtract it from 1 because we're going to bring it over here to the other side. So mathematically, we're just algebraing this over here, and there's our answer. So let's go ahead and solve it. We have now solved for what we're looking for right here. 0.44, 2, 3, 4, 1 minus And that's the answer. Do we have to move decimals? What do we got to do? Report your answer to 3 decimal place accuracy. Please tell me that has a margin error on it. And then Leanne says, can we do the canvas? I am 95% confident has limits. Let me see. Which one is that? It's not on this one. So we answered 2 questions, right? So we should get a 4. I'm fine with that. We should get a 4. Be very mad if we don't 4. Yay, we got a 4. I didn't get these wrong. I just didn't answer them. Does it have a plus or minus on it? I'd hope that has a little bit of a plus or minus. I try to put plus or minuses on them. Let me find that question you have. Someone shows that. And they're like, Brian got a 4. Got a 4 out of 4. So for this one, we're doing the margin of error right here. I think you've got the Z. Yeah. You have it right here. Oh, I see what you're saying. So you're trying to find. Is this the one you're doing right here, Leanne? Can you confirm? And great job, Krista. Let me throw some 100 points. I've been throwing some big points lately. Thank you, Leanne and Krista. Great job right here. And we'll be ending office hours here in like 10 minutes because I've got the meeting at 1:30 your time. Is this the one you're working on right here? So here's where this one gets a little bit tricky. And I had an A student, like a student who was acing the class, who got to this question and they said, I don't have enough information. They were acing the class. And I was like, you can solve it. And they're like, I don't know what p-hat is. And I was like, well, you can. It's like, it doesn't tell me what p-hat is. And I'm like, but you don't need that. And they're like, but I do need that. They're like, the formula. And I'm like, but there's ways. And they're like, can you tell me? And I'm like, nope. So don't worry. I do remember that. It was in Alumni Memorial Auditorium. I remember that conversation. They're like, you can't solve this. And I was like, but you can. But you can. And the answer is right here. I might have to go back in time on this document a little bit to show how to solve it. The answer is right here. So I want you to look at this here for a moment, Leanne, and just start thinking about it and being like, what information do I have? You can actually get p-hat. It showed how to get p-hat a moment ago. Like, you can kind of see, like, you're right now given on this problem, you're given this information right here. That's the information you're given in the current moment. You just have that information. So you could technically find this right here. You could find that if you really wanted. Then you could go through the steps of probably solving it. And that would just be more work. It'd be a lot longer of a solve to get p-hat, which would be the average of those 2 numbers. So you could get p-hat, then get q-hat. But you don't know the sample size, right? So yeah, actually not knowing the sample size, you'd get stuck then. So that would be, yeah, you wouldn't be able to do it really. But what do you think you're going to do with those numbers, which I can kind of see the answer to yours. Can you see what to do? I just want you to be looking at this for a moment right here and be thinking about what you'll do to solve this right here, how we're solving for this interval, getting the margin of error. Yeah, Leanne, you see it. You say, oh. The student, when they were like in Alumni and they're like, well, I can't solve this. And I was like, you can. And then they're just like, and they were an A student. Like, they had aced every test. Like, they only needed to get like a 40 on the test to pass. I mean, not pass the class, but get an A in the class. They had like a 99 average. And they're just like, you can't solve this. And I think sometimes we get a little too stuck in the kind of sense of, like we see formulas and we're like, okay, I have to use this formula. But all this is the margin of error is half the length of the interval. So the margin of error is just half the length of the interval. We just get the distance these numbers are away, get half the length. I think we've only answered that question. And that should do it. We should get 2 out of 2. I like I like people in the chat being like, oh, that's how we do it. And so don't worry, I didn't answer that question. Unanswered. But once you see it, it's like, okay, the margin of error is half the length of the interval. Additional questions. What do we have? We only got like 5 more minutes. Sorry for all the streaming issues. If people didn't see at the start of office hours, I actually contacted the people. There's me right there, B. Stevens. Hey there, we are currently aware of an issue. When using ultra low latency setting, can you turn that off and try streaming again? Yeah, the 95%, I guess that's a trick part of it, right? We're just trying to trick you right there. I'd say, yep, ignore that. Yep, that is unimportant information. It might as well just say lower is this, upper is this, what's half the distance, which is the margin of error. So the 95% confidence. Now, a really hard question would be reverse solving this for the sample size. A really hard question right here, it would just be a bunch of mathematics to reverse solve it. So the center of this interval Like, I would not love this. It would just be too much work. We do have some questions that are a lot of work on the test. And it's a lot of work. 0.691. So reverse solving it. This would not be a fun question. So we know p hat is equal to 6.91. Q hat is equal to 0.309, just the complement of that. Z is equal to 1.96. And then we know here, I guess we only have to do the margin of error, right? So we could do the margin of error is equal to, because we just calculated the margin of error. The margin of error was equal to 0.038, was it? What was it? Yeah, it was 38. And so now we could get the margin of error is equal to square root p hat. No, z. There's your z. That's way too small of a z. This is a way worse version of the problem, like solve for the sample size. And so now we just plug and chug into the problem. So 0.038 equals 1.96 square root. And then we put this in right here, 691 times 0.309 over, and then n, and we solve. I think we actually have the reverse solve for this. I'm trying to think from memory what it is. I think when you reverse solve this, it is, we solved this out earlier, p hat, q hat, the z is going to be on the bottom. No, z is going to be on top. That's it right there, equals n. So that's the reverse solve. This is a much harder problem. So the sample size, I am halfway interested in what sample size whoever created this used. 1.96 divided by 0.038. This is just you're not going to be solving this problem. And then times that by, I want to see if it's like a nice, neat number. That's interesting. 568.04. Yes, that's a pretty crazy problem right there, especially if we were to ask you to reverse solve for the sample size. So that would just be a big algebra problem. Not that fun, not that cool. But let's head over here to space. I'll be adding in those Kahoot questions. I'm going to switch over here to this. I'll be adding in those Kahoot questions here in a little bit. So stay tuned for the Kahoot questions for the test. Any last questions here before we head off? Sorry for the short office hours today. Meetings. People want to meet. And we have to meet. We have to talk about Stat 201. Leanne and Krista and Layla, great job today. Did anyone else swing by? I think Charlie swung by to say hey, and Ritu swung by. Good seeing you here. Let's throw out some more points. I'll be replying to everyone here in just a moment. With that, we'll end office hours, but I'll be answering emails. Email questions if you have them. Let me know. But we'll be back. Prepare for the test. I'll be sending out some email reminders. Here we go, everyone. Bye for now. Bye for now, everyone. Bye. I'm Mubot. Bye.
I am Mubot.